Hi, this video is from Monday, April 20th for calculus. So today I'm going to be teaching you about arithmetic and geometric series. So those are different from sequences because they are the sum of a sequence. So an arithmetic series is the sum of an arithmetic sequence, just like a geometric series is the sum of a geometric sequence. Okay, so I'm going to give you examples. So an arithmetic series could look like this. 3 plus 7 plus 11 plus 15 plus ... plus all the way to 99. So this is still separated by a common difference, 4, because you're adding 4 each time to get the next number, but it's a series because you're adding the whole sequence together. Okay, the first term is still called A1. Like I said, the common difference between them is 4 because that's what you're adding each time. And then n would be the number of terms, but here I didn't specify what that is. Okay, there are two formulas. First formula looks like this. This stands for the sum. Okay, so the sum equals n times a1 plus an divided by 2. So that is the first formula. Okay, second formula, as n equals n divided by 2. 2 times a1 plus the difference times n minus 1. Now, on your notes, this formula looks slightly different because the d is behind this quantity n minus 1, but it really is just telling you that you're doing n minus 1 and then times the common difference. Okay, so that's what that's about. Okay, now you might be asking, well, how do you know what formula to use? Well, it's basically what information do you have? Okay, and sometimes you could use either formula, but I'm going to practice using the first formula on example 1 and the second formula on example 2. Okay, so are you ready for that? Alright, example 1, we have A1 equals 42, n equals 14, and an equals 146. Now here, I literally could not use the second formula because I don't know what the common difference is, so I have to use formula 1. Okay, so formula 1, we're going to take n, which is 14, times a1, which is 42, plus an, which is 146, divided by 2, like that. Okay, so this turns out to be 14 times 94, which equals 1316. Okay, so the sum of that arithmetic sequence, so the arithmetic series, equals 1316. Alright, here we go, example 2. Okay, example 2, we have 6, 11, 16, 21, 26, 31, and 36. Okay, here I'm going to have us use the second formula, even though you could use the first if you wanted. So here we have, let's count them, 1, 2, 3, 4, 5, 6, 7 terms. So n is 7. Okay, the first term is 6. The last term is 36. Now the difference, what are we doing each time to get the next number? Well, we're adding 5. So the difference is 5. Okay, so like I said, I'm going to have us use the second formula, but you could use the first if you wanted. Okay, so here we go. N divided by 2. 2 times a1 plus the difference times n minus 1. That's the formula. So we're going to plug in all of that stuff into that formula. So we have 7 over 2, 2 times 6, plus 5 times 7 minus 1. Like that, okay? So 7 divided by 2 is 3.5. 2 times 6 is 12. And 7 minus 1 here is 6. So 5 times 6 is 30. So 42 times 3.5 equals 147. Okay, so if you were to add all those numbers together in that list up there, it would equal 147. Okay, so that's example 2. Those are our arithmetic series. Now I'm going to teach you about geometric series. We're going to have 2 formulas for that as well. A geometric series is the sum of a geometric sequence. So that means we're multiplying by something each time to get the next number. And we're still going to have a first term, a1. And n is still the number of terms in the sequence. So there are 2 formulas for this also, because geometric series, we're going to look at finite, meaning it ends, and infinite, meaning it doesn't end. Okay, you might be thinking, well, how am I supposed to find the sum of an infinite series? Well, you just try your best. Use the formula. Think it over. Okay, it's more about like, does it converge or diverge, what we studied last week. So we're going to go with that. Okay, so the formula for finite is going to be a1 times 1 minus r to the n over 1 minus r. And the ones for infinite is going to be a1 divided by 1 minus r. Okay, so first we're going to have an example of a finite geometric series. Like I said, finite means that it ends. So here's our example 3. We've got 81 plus 27 plus 9 plus 3. And you might be thinking, you said we were multiplying by something to get the next number. Well, we technically are, because even though these are getting smaller, and you know that 9 divided by 3 is 3, and 27 divided by 3 is 9, and 81 divided by 3 is 27, dividing by 3 is the same as multiplying by 1/3. So our r, our ratio, is going to be 1/3. Our first term here is 81. And how many numbers are in this sequence? 4. So n equals 4. So our formula, I'm going to write it again. a1, 1 minus r to the n over 1 minus r. We're going to plug in all the stuff now and get the answer. So 81, 1 minus 1/3 to the 4th divided by 1 minus 1/3. Okay, now I typed on your notes page how to type this in directly into your phone calculator so that you could get the answer. I hope that that is somewhat clear. I typed it in exact order of how you should do it on your phone calculator. So you would do 81 times 1, parentheses, 1 minus 1 divided by 3, and then you press the X to the Y button, 4, parentheses, equals, and that should give you 80. So the top part of this thing equals 80. Okay, then divided by, parentheses, 1 minus 1 divided by 3, parentheses, equals, and that'll give you the whole final total answer. And if you look at this, 1 minus 1/3 should be 2/3. So you're doing 80 divided by 2/3. That's what your calculator's doing. And it should equal 120. Okay, so the final total answer to that should be 120. And if you want to check it out, see if it's right, Add up those four numbers and see if it equals 120. Okay. Alright, lastly, we have example 4. So, this is an infinite geometric series. Okay, so the formula for that was a1 over 1 minus r. So, we have a1 equals 1 and r equals 1/2. So, we're going to do 1 over 1 minus 1/2. So 1 divided by 1/2 is 2. Okay, so that one is 2. So your Google form for the day is only 4 problems, and it's exactly like the examples, meaning in the same order, you do the same formula. They're obviously different numbers, but so for the first one, you'll use arithmetic series formula 1. For the second one, you'll use arithmetic series formula 2. And then you'll use geometric series formula 1, and then geometric series formula 2. So if you need any help with that, or using your phone calculator, or if you're trying to submit this Google form and that doesn't work out very well, or any of your Google forms for that matter, please let me know. Like if you've been trying to submit these and your grade still says that you have incompletes, please communicate to me. Because I want to make sure you get your points. I don't want you to not get your points. So I hope everything is going well for you and that, you know, you're getting close to being done with school. And I know that's very sad and exciting and crazy and scary all at the same time. But I'm very proud of all of you, and we'll wrap this up soon. And I miss you, and I wish I could be there in person to see you and, you know, teach you math. That'd be nice. See you tomorrow. Bye.